Habari, karibu katika series zetu za Advanced Physics, na leo tutafanya lesson yetu ya 15 Waves and Vibration. As usual, my name ni Constantine Alex Tanguligwa from Muhimbili University of Health and Allied Sciences. According to our syllabus, topic yetu imegawanyika katika sehemu kuu 4. Part ya kwanza itakuwa inahusu mechanical vibration, part ya pili itakuwa inahusu wave motion, part ya tatu itakuwa inahusu sound, na part ya 4 ambayo ina content za kutosha na ni ya muhimu sana itakuwa ni physical optics. So back to the basics. Kabla tujaanza tufanye revision for the basic concepts kuhusu waves. What is a wave? Basically, a wave is the transfer of energy from one point to another without transfer of medium as a result of disturbance. Okay, ongezea hapa as a result of disturbance. As a result of disturbance. So it's the transfer of energy from one point to another without the transfer of medium. Okay, as a result of disturbance. Or you can put it either way. You can start is the transfer of energy from one point to another, okay, due to disturbance without transfer of medium. Add this word disturbance is very important because, for example, ukiwa na ndoo ya maji au beseni, okay, ukiligonga pembeni utaona kuna mistari au maduara yanakuwa formed kwenye maji. Ile ni waves, sawa? So pale kuna energy inakuwa transferred from one point to another. The water inabaki pale ndani ya beseni, hai transfer, lakini energy inakuwa ina pass through that medium water, lakini as a result of disturbance ulivyopiga ile ndoo au ile beseni. So basically tuna two types za waves, tuna mechanical waves na electromagnetic waves, okay? Generally the cover that carries the meaning of the two ni kwamba moja ina require medium, moja hai require medium. Ambayo ina require medium ni mechanical. As you can see, it is mechanical. Make it that way, mechanical. So it needs something which can be touched, okay, something that should be present, mechanical. So that requires a medium. While electromagnetic wave does not require a medium. Ndio maana electromagnetic waves zinaweza kupita hata kwenye vacuum. So for the mechanical waves tuna two types, tuna transverse waves na longitudinal waves. Tukiambiwa to illustrate wave, basically wengi tunajua this. So we know these are troughs, these are crests. Okay, milima na mabonde, troughs and crests. So hii huwa ni transverse wave, ni type ya mechanical wave ambayo ina travel in terms of crest and troughs. So what happens here ni kwamba the particles are moving in different direction to the energy. As you can see, the wave passes the energy that direction, but the particles vibrate up and down perpendicular to the direction of the energy. Okay, so the particles vibrate, no matter vinakuwa na maximum amplitude, they come back to zero, they come back here. So the particles of the medium move perpendicularly to the direction of the energy. So it travels in terms of crest and troughs. While for longitudinal waves, it travels in terms of compression and rarefaction. We know if you have a person, okay, basically tunafahamu mfano mmoja mzuri wa longitudinal waves ni sound. So what happens when a person is speaking? Mtu akiwa anapiga umbea wake, anakula ubuyu hapa au sio, anapiga zake umbea, pale ambapo anatoa sound, okay, kunakuwa na very high compressions. Okay, zinakuwa na very high compressions. So as the sound moves, okay, it moves to regions which are the particles are far apart, rarefactions. Okay, so inakuwa ina compress where there is high magnitude of sound, so it moves towards sehemu ambapo kuna rarefactions, sehemu ambapo haziko compressed, sehemu ambapo particles ziko zimeachana. So zikifika pale zinasababisha compression, they move that way mpaka inamfikia anayesikia. Okay, compression and refractions huko ni crest and troughs. Again, one important factor ya kufahamu kuhusu compression and refractions ni kwamba particles move in the same direction as energy is going. Mtu anaongea, sound energy moves to the right kwa mfano, and the particles will be moving to the right also. Okay, maximum, minimum, maximum, minimum, maximum, minimum, maximum, minimum. So the direction of movement of the particles is the same as that of movement of energy. That's why you see it moving that way. You remember, for transverse, particles move perpendicular to the direction of the energy. They move up and down while the energy moves to the left. So basically tukiamua kudifferentiate, okay, tukidifferentiate transverse waves na longitudinal waves, kwanza tutasema transverse waves move in terms of crest and troughs, while longitudinal waves move in terms of compression na rarefaction. Lakini cha pili tutakachosema ni direction ya movement ya particles. In transverse waves, note, andika hichi kitu, okay, andika hichi kitu. In transverse waves, particles move perpendicular to the direction of energy. Okay, in transverse waves, particles move in perpendicular to the direction of energy. Okay, while for longitudinal, the particles move kwenye direction ile ile ya energy. Okay, so hizo ni difference mbili za muhimu. Lakini ukidifferentiate transverse, ukidifferentiate mechanical na electromagnetic, utasema moja ilikuwa medium na nyingine hailikuwa medium. Here are other differences between transverse and longitudinal waves. As you can see, moved in terms of crest and troughs, formed as a series of compression and rarefactions. So the transverse waves propagate only in solids and at the surface of liquids, while longitudinal waves can propagate in all types of media. As you know, sound can pass kwenye solid, can pass kwenye liquid, can pass kwenye gas. Sound can pass anywhere, okay, anywhere. But here propagate only in solids, okay, and at surface of the liquids. Kwa mfano ule mfano naokupa beseni, ukilitingisha ile ni transverse waves, lakini inakuwa ni kwenye surface za liquids, cannot move kwenye gas. So here there are no pressure variations, while in the longitudinal waves there is pressure variations. So ndo maana kunakuwa na maximum, kunakuwa na compression na rarefaction. So pressure and density ya maximum kwenye compression na minimum kwenye rarefaction, namna hiyo. So cha kuongezea hapo, usisahau the direction of movement of the particles. In transverse, particles move perpendicular to the direction of energy, while longitudinal particles move into the direction of the movement of energy. Naomba usisahau this last point, very important.